Yeah?
Spelled brake wrong.
Oh, you're right. Thank you.
That way too.
Thank you. So funny. Okay, so if we're in a horizontal line, can you guys see this? If the acceleration is positive, you really can't see it?
On the paper you can.
Yeah, on the, not on here, but on the paper you can see it, right? If the acceleration is positive, that means that the object is accelerating to the right, okay? If the acceleration, or if it's vertical, you're accelerating upwards. Acceleration is negative, it means you're accelerating to the left. If the acceleration is 0, that means the rate of change of your velocity is nothing. That means your velocity is not changing. Does that mean the particle is stopped? No, it just means the velocity is staying constant, okay? Good. Now, because an object's velocity is 0 does not mean that the object is stopped. It means that the velocity is not changing. What device do you have on your cars that keeps the car's acceleration equal to 0? Do you guys know?
Cruise control.
Yes. Have you guys ever used that? Oh, no, you guys don't drive, do you? Some of you drive. It's kind of dangerous. You only use it when you're driving like really long distances on open freeways. Like if you're driving to San Francisco, let's say there's this big open freeway, nobody's on it, and you're getting tired holding your foot on like the 80 mile per or like the 65 mile per hour, like, you know, pedal, and then you could do cruise control. So you could push this button. It's usually on your steering wheel, and then once, let's say you're going 65 and you press it, your car will like, you'll feel the pedal go, like it'll kind of indent a little bit, and then it'll stay at 65. So you can move your feet off of the gas, and then the car will just consistently go at 65.
But you still have to hold the steering wheel.
Of course. You don't just like go to sleep.
Unless your car is like imbalanced, right?
Yeah, right. Of course you still hold the steering wheel. You're still driving. You still have to be alert. You still have to be ready to press on the brakes if something happens, if like a deer comes in front of you or something. But the nice thing about cruise control is that because you're not accelerating, and you're at your acceleration is 0, that means your velocity is constant. You don't use gas. Literally, because you're not pressing on the gas. So you save money. Yeah, that's the benefit. Because if I go 65, 80, 65, 80, 65, 80, and go back and forth, every time I press the gas, I'm expending more energy. So you're going to have to pay more. That's why you spend more gas when you're stop and go traffic. You still spend some gas, but you don't spend extra.
You're not making it go fast.
Exactly. But if you go consistently at 65 the whole time, you're saving money.
Yes, I can feel it.
And actually, there is like a there is an optimum. I think 55 or something like that is an optimum speed where your car uses like very little gas. Okay. Anyway, just because you have a positive acceleration. Okay, now this is important, y'all. If you have a positive acceleration, does that mean that you are moving to the right? Well, moving to the right means you're going forward.
No, if it's positive, it doesn't mean you're just like you're accelerating. Because
yeah,
if it's negative, you're decelerating.
Okay, so it doesn't always. Okay, yeah, it does mean you're accelerating, but what does that mean to you?
It means you're going
Getting faster? Not necessarily.
in the position that you're.
It depends.
In the direction.
Okay, that's why they're telling you to think of acceleration like a wind. Okay, so if positive acceleration means it's the wind pushing you to the right. If I'm already going to the right. Okay?
And the wind pushes you going fast.
Exactly. Where's this other video?
And then like if the wind pushes, if you're walking in the same direction, the wind pushes you back.
Exactly. Okay, I need a volunteer. Somebody from over here.
No worries.
Nobody wants to help me out?
What? Is there like a barrier here?
How come every time I do video I'm wearing this dress? The YouTube universe is going to think I wear this dress every day. Okay. Hey, Robert, you're going to be my wind. Okay? I know, but I thought about it. Wouldn't he be a good wind? Okay. You guys see that? Come on, Robert. Come on, hurry up.
Oh, you're her wind.
Okay, so this is positive and this is negative, okay? So let's say you stand there and you're just going like this. Okay? What kind of acceleration? Okay, what kind of
You gotta move your fingers.
Okay, you know, just stay there. Let's move the camera. What kind of acceleration is this? What kind of acceleration is this?
Positive.
Positive. Okay. Now let's say I'm going this way. Okay. Yeah. Yeah. Keep going. Keep going. Let's say I'm going this way. So what sign is my velocity?
Positive.
Positive, right? I'm going this way, so my velocity is positive. Now start blowing. Okay. So acceleration is positive and velocity is positive. So what effect is he gonna have on me?
Positive.
Yeah, no, but what in real life? Well, how's that gonna feel like? I'm gonna speed up. I'm gonna speed up. He's pushing me, right? Acceleration is still positive, but now I'm going this way. So my velocity is what?
Negative.
Negative. My velocity is negative, but he's pushing me. So what do I do?
You're going to
Slow down.
And that's going to become negative.
Okay, I slow down. So even though my velocity is still negative, let's say I was going 50 miles per hour this way, so negative 50, negative 40, negative 30. Oh, so much wind, right? You get it? Okay. So my velocity is still negative. I didn't cease to be negative. My velocity, because I was going to the left the whole time, but my absolute value, my speed, decreased because he's pushing me. Okay. Now, can you like make noises too? Like that would help. Because everybody's learning at stake. Okay. Now what's acceleration is what? Negative. He's pushing this way. So when my velocity is positive,
Acceleration.
I'm slowing down, right? So my velocity, I was going 80, and then I was going 70, and then I was going 60, and I slowed down, okay? Versus if my velocity is negative, and his acceleration is negative, what's going to happen? I speed up. Thank you.
So your velocity.
You're a great win. If
You're
you're
gonna
gonna
play,
play,
you're gonna play
Your velocity
negative,
will become
negative.
negative.
Yes. Yes.
So acceleration would, okay, so as you're slowing down, is your acceleration then negative?
Yes, we're gonna talk all about it in this handy dandy chart right here. Okay? So
You'll have to be one of the
what is going on here? How do I do this? Hello. This is so confusing. How do I? Okay, there we go. You guys see that? Okay. 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 So this is what you guys see, and it's what the video sees. Better. Okay. Better. All right. Okay. So blah blah blah. For instance, suppose you're walking to the left, to the right, when all of a sudden a huge, large wind starts to blow to the left. What would that do to your velocity? Yeah. Slow you down. You like my writing? Slow you down. Okay? Okay. So, given that a particle is moving along a horizontal line, let's just talk about horizontal movement here, with position function, that's our position function, okay, that we're dealing with. The velocity function, what is the velocity function? Can we find the velocity if I give you the position?
Yes.
Doing what? Yeah, so what's the derivative?
S prime t.
Which is 2t minus 4, right? Which is s prime of t. Yeah? Nice.
What is the function?
It's a function, so it tells you at any given time. You could plug in a value for t, right? Acceleration is 2. That's right. What does that mean? That the wind is constantly blowing, right? With a force of 2. Okay. Let's complete the chart for the first 5 seconds to show where the object is on the number line. All right. Okay, so how about this?
Wait a second.
All right, let's just do it. So at time 0, what's the position? Let's plug it in. 2, okay? I want you all to do this, okay? You guys see where I'm getting this number? If I plug in v of t, so if I plug in 2 into the velocity, what do I get? Negative 4. Absolute value of that is positive 4. Acceleration, 2.
Wait a second.
Wait. What?
T equals 0?
Why is it accelerate?
Yes, t equals 0.
Oh, you get 2, and then.
And I plugged 0 in here. 0 times 2 is 0 minus 4. Okay? You see the absolute value, guys?
So the acceleration
It's 2. It's always 2, isn't it? Okay.
will it
What is
always
that?
be 2 forever?
No, in this equation, because it started out as a quadratic, right? And then when you do the derivative of that, you get a linear, and the derivative of that is just constant, right? Well, that's cool.
Is there a form?
What is that?
Is there a form? 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 Is
There can be, you can have a 30-second prime.
But what does that mean?
Oh, physics, yeah, in our universe it probably doesn't have much meaning, but you can, right? Okay, so what does this mean? What happened to the particle's motion? It was moving to the left, and then the wind was pushing it to the right, so it slowed down. Okay, so you know what? Let's write that. Let's write all of that. Okay, moving to the left, slowing down. Okay? All right. Let's plug in 1. Okay? Let's just, to make sure everybody's doing enough, their fair share of thinking, let's just call on people, okay? So tell me, if I plug in 1 second for the position, what will happen? Okay, Ronica, what's the position? -1. Okay. Veronica, what's the velocity? Well, I plug in 1, so 2 times 1 is 2. 2 minus 4? -2, right?
So you don't plug in this for that? You just plug
No,
in
no, no, because it's v of t. It's not v of s of t. It's not a composite function, right? You're just plugging in 1 to here. 2 times 1 minus 4 is -2. Absolute value of that, everybody? Is 2. And the acceleration is 2. Might as well just do this, right? The acceleration doesn't change, right? Okay, so tell me what happens, Arlene, to this particle. How can we describe it?
It's going to the left,
Okay.
and the acceleration is so slows down.
It's slowing down, yeah? Which makes sense because remember this represents speed, right? The absolute value of velocity. The speed was 4 here, but now the speed is 2. Didn't we say it was going to slow down?
Yeah.
And it did, right? Because it was supposed to slow down. And look, the speed went from 4 to 2, so it did slow down. Yeah? Is that cool? Is your brain just like totally on overload from trying to make all these connections?
There's 2 speeds in there?
Yeah.
Oh no, that's position. So it started at 2 then, and then it went to -1.
It started at 2 and it went to -1. So it was started in a positive place. Wait. It started in a positive place and it moved back. Didn't we say it was going to move to the left? Yeah. So let's chart it.
So it's going to move against the left?
decelerating?
That's a good question. It's not decelerating as long as actually we're going to talk about that here. As long as the acceleration is positive. Well,
Well, is the acceleration positive because it's pushing
yeah,
to the left
acceleration
or
is
to the
2.
right? Can it be
The
negative?
movement.
What would it be? So acceleration is always positive.
No, in this
No,
case
in
it's
this
positive.
case it is.
Remember when when Robert was pushing, the wind was blowing that way, then the acceleration was positive. When Robert was pushing the other way, then the acceleration was negative.
Oh.
Remember? So, okay, let's actually plot this. So at time 0, this particle started at 2, right? Okay, so time 0, we started here. And then where did we move? Our little dot friend. To the left, it moved to -1 at time 1. Time 1. Okay, so it moved to the left just like we said it would. And it slowed down because it was going much faster when it started and then it slowed down. Okay? Next. When I plug in 2, Daisy, what is my position? -2. Okay? And then what is my velocity, Brittany? 0. And so my speed is still 0. Okay, so tell me what that means, Cassandra.
Wait, from where?
From the third line?
From the third line, it is going.
Is it moving left or right?
It's moving left
Why?
because it went from -1 to.
When you for the direction, you just look at the sign here. Is it positive or negative?
Oh.
Well, the sign is nothing. It's 0. So is it moving left or right? Neither. What does that mean? If you're not moving left, you're not moving right. What are you doing? You're staying still. That's right. So you're stopped.
And then you're gonna start going to the right.
Okay? Why would you start going to the right after that?
Because now
Because the wind is pushing you to the right.
Yeah.
So, okay, the acceleration is, okay, look. Okay, so you're stopped, but the wind is pushing you to the right. So now you're gonna, are you slowing down or speeding up? You're gonna start to speed up, right? Or you're not speeding up because you have no speed. So pick up speed, I guess. Accelerate, okay. Okay, so let's see what this looks like in the picture. At time 2, where am I? I'm over here, right? So I moved to the left like I said I would, and I slowed down, but I stopped. What do you think is going to happen?
It's gonna turn around.
It's going to turn around? Probably. How would we know if it's going to turn around?
Because the acceleration.
Okay, but what else tells us that, what information that we haven't gotten yet would tell us, will prove to us if it has turned around?
If you plug in 3.
If the next point is what? What's positive? If the velocity, right? Because the velocity tells you the direction. If the velocity was negative, it was going left. But if the velocity after this becomes positive, now it's traveling right. At this moment in time, what is it, left or right? Neither. It's not going anywhere. It's stopped. The only time you stop is if you're like at standstill literally, or if you're turning. Right? Because if I'm going this way and then I'm going this way, it doesn't look like I stopped, but for a second I must have stopped if I turned around, right?
You did.
Yeah, like what?
Am I stopping? No, but am I stopping? Yes. Doesn't look like it, but I did stop for a second in order to turn around. You also are at velocity 0 if you're like this. And then the minute you know, right before you started walking, you're also 0 then, right? Okay.
Oh, the zooming in?
Well, not really. Not the instantaneous velocity. Okay, anyway. All right, next. Because here is where we start. Well, maybe because maybe before I was already walking, but we just started timing it right this moment, right? Okay, Josue, tell us what happens if I plug in 3.
3. You get
9 minus 12.
You get -1.
Negative 1. Okay, if I plug in for velocity, Catherine, what do I get? Okay, 6 minus 4 is 2. The absolute value of that is 2. Okay, so tell me what this means, Haley. So moving to the right, what do you mean 2? It's just moving to the right at a speed of 2, yeah? And then what about, am I slowing up or down, or what? Speeding up, how come? Because the acceleration is positive and because my direction is positive. When my direction and acceleration are both have the same sign, that means you're speeding up. Because you're going positive and the wind is blowing positive. Okay, so let's plot this. So here at the next moment I'm at -1. So I'm back here. So I'm going to just draw it up here, okay? So this is t, even though you guys know there is no actual y-axis here, this is all just on one straight line. You understand that, right? I should have just drawn it on the axis like this. But I wanted to show you the turn, and it's kind of hard to show. So t equals, at the 3rd second, we moved and we turned around. So we moved this way.
Will we get to a y?
Actually, no. We mainly talk about vertical or horizontal. I think we'd have to get to parametrics, which would have been the next
For the
level of
third
calculus.
dimension?
Actually, no, we do.
We
Yeah,
get
we
to
do. We do, yeah. We do.
Y and z?
We get into xy, not the z 3rd dimension. That's in like level 3 calculus. Okay, so all right, so which you're gonna need if you want to be an engineer, and like things in life are 3-dimensional, right? Okay, so 1, 2, 3. Okay, so did our prediction come true? Did we pick up speed? Did we stop? Oh, we should probably say we're about to turn. This is a turning point, right? But we didn't really know that until we checked that it was negative here and then positive there, right? Okay, the turning point is accounted for. I'm going to put a star here. The turning point is because we went from negative to positive. So that right there gave me a turning point. Okay? All right, so I'm speeding up. I'm going faster. By the way, how do we see speed here? Because this just tracks, this is a tracker for position, right? This whole thing is a tracker for position.
Can you track speed, how much it moves?
Yeah, because each increment is just 1 second, right? But look, this guy, this little particle buddy, moved this much in 1 second, and then they only moved this much. So didn't that mean he slowed down?
Oh, let me tell you, because of physics, right?
Okay.
The distance, when the distance between two objects is shortened, the force gets stronger.
Oh.
So the force of the wind got stronger as the object got
Okay.
closer to the wind. Yep.
I feel you.
If
Sounds
it was
good.
Like a fan or something.
Okay, okay. Or a Robert
Or a
waving
Robert.
his arms. Okay, so you see how this is speed? The speed here got smaller or less? Okay, now it looks like the speed here is the same, right? Because in 1 second they moved 1 over, and here in 1 second it moved 1 over. So here, do you notice how the speed is the same? Okay, now, but we think the speed should get faster because the acceleration was causing it to speed up. So what's the next one then? Somebody tell me. Like Alejandra. If you plug in 4, what do you get? 2. 16 minus 16 plus 2. And if I plug in velocity, what do I get, Anna? Okay. No, you get 4 actually, because 2 times 4 is 8. 8 minus 4 is 4. Absolute value is 4. So what does that mean, Sky?
It's moving to the right and speeding.
Yep, it's speeding up again. So right here I'm at 4. I sped up a lot. I got real far. I covered a lot of ground in that short period of time, in that 1 second of time, right?
So the line is representing velocity. No,
Position. Question?
shouldn't it be at 2?
Oh, I'm sorry. Thank you. I'm always making those mistakes. Yeah. Okay. And then lastly, let's just do this real fast. So at 5 seconds, you plug in 5. 25 minus 20 is 5 plus is 7. We're at 7. You plug in 5 here, so it's 10 minus 4 is 6. 6. Okay. So we're still moving to the right because the velocity is positive, right? And we're still speeding up because the velocity is positive and the acceleration is positive, which explains why we got all the way over here by the 5th second. We moved so fast that we made all this progress. Okay? Does that make sense? All right. It is too much to do such work. So this is the last time we'll do it like that. Okay?
Oh, the shortcut?
Yes. Okay, it is too much to do such work for complicated functions. We are generally interested when the particle is, the things that we really care about is when the particle is stopped or when it has no acceleration. Okay? We're also interested in when the object is speeding up or slowing down. Realizing that an object's velocity is either positive, negative, or stop, 0, and an object's acceleration is positive, negative, or 0, constant speed. These are good things to know. I'm just going to put a bracket there or something. We can now use a chart to determine all the possibilities in an object's motion as if you were looking at it from above. Okay?
So we're not, they don't care about the numbers, they just care about whether it's positive or negative.
Who's they?
Or calculus.
We sometimes will care about the numbers, actual values, but we care more about the sign. Okay, but we will care.
AP test?
Yes, we will care about the values. Yes. Okay, I would be lying if I said we don't. Okay, so all right, so let's do this. If the velocity is, what does this mean? Velocity is positive and the acceleration is positive. What's happening?
Moving right.
Speeding. Okay, moving right. Let's do this. It's moving right and it's speeding. Speeding up. Okay. Velocity is positive, so it's moving right the whole time, right? Okay, moving right, and this one is speeding down. Oh, sorry. Sorry. I should write the word. I think I'm confusing you guys by not writing the whole word. This is moving to the right because the velocity is positive. This is still moving to the right, but this is slowing down, right? Okay? Because the velocity is positive, but the wind is blowing you against you. Yeah.
So then that one is constant.
Okay. Now what about when velocity is positive? It's still moving to the right, but the acceleration is 0. There's no wind. Constant speed, yes. But which direction are you moving?
Constant right speed.
Okay, constant speed. Or constantly moving right? Constant speed or velocity, okay? Alright, what about when the V is negative? Then we're moving left, 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 right? That's the only difference. But we're still, okay, now, no, that's not the only difference. Otherwise we wouldn't need this chart. Okay, velocity is negative, so we're slowing down. However, what is happening? But the acceleration is positive. I'm going to the left, but the wind is pushing me to the right. So I'm slowing down. Does everybody see that? Okay, here I'm going to the left, and the wind is pushing me to the left, so I'm speeding up. Here I'm moving to the left, and the wind is not existent, so I'm going to the left at a constant speed. Okay? What about when velocity? Okay, let me give you a minute to let that sink in.
Ooh, wait. Your velocity, that means you're staying, but your acceleration.
Means you're not moving, right?
You're not moving, but your acceleration is positive.
You're still not moving.
You're being pushed.
Okay, if your velocity is 0, what's happening?
You're not moving.
You're not moving. So let's say that we are stopped, okay?
Okay.
No matter what, we're stopped. But that doesn't mean the wind is not blowing. Okay?
You could be shifting your ball.
So, what happens? If the acceleration is positive, you're stopped, but you are still accelerating. Okay?
There's no force back.
You're accelerating to the right. Here you're accelerating to the left, and here your acceleration is 0. How should I say this?
You're still stopped.
There's no acceleration.
So you're not moving.
Well, either way, you're not moving. And all three of this, it's confused. It's in a sense it's misleading because I'm saying you're accelerating to the right, but you're not moving anywhere at that
So
instant.
how can you do that?
But
How
you're
can
about
you
to.
accelerate?
How's that
It's not
how can you do an
moving.
example of that?
Well, that's just it's just a different idea of what it means to accelerate.
Is that kind of like when we're just like, and like the wind is just blowing us? We're
And
just
like
Yeah,
but
I
you're
guess.
standing here and you're, like,
But
pushing against
you're
it.
about to get moving.
Ooh, like
I don't get it.
static.
Maybe it's like static force, maybe.
Yeah, the thing we're reading about.
Yeah.
Bro, I'm telling you, physics coming in.
Well, physics, I think it's really good that you guys are taking physics at the same time.
Be a
Well,
physicist.
not all of you are you?
Yeah.
Okay, well, you all have had it or are taking it. That's pretty cool. Okay, so you know what, you guys? Let's hurry up and get through this one example. Okay. All right, we're moving on. The particle is moving. Hey, yo. Particle is moving. I just want to make sure I'm not going to teach you the wrong thing. The particle is moving along a horizontal line with a position function here. Here's a new function for us, okay? Okay, Robbie, you still with us? Robbie, Bobby? Okay, do an analysis. So we're going to do an analysis. Didn't I tell you we were going to analyze?
Yeah.
Do analysis of the particle's direction, acceleration. These are good words. Direction, acceleration, motion, and position. Okay? So step 1 is to find the velocity, which is a derivative. So it's 2t minus 6. And the derivative of that?
Students, the Bible club with Miss Han has been postponed today. It'll be postponed until Thursday. Boys basketball, you have a meeting in room 24. Thank you very much.
Okay. So a v0 is, okay. So when is the velocity going to be 0?
Oh,
When T is 3.
You all agree with that?
Yeah.
Solved for the 0 of that, t is 3. That's important. We always want to know when the velocity is 0. That is called a critical point, guys, or critical value when the velocity is 0, or when the first derivative is 0. So let's go ahead and put 3 right here on our number line.
Attention, teachers and students. Please listen carefully to this message. If you are a student who is running for representative, please report to Mrs. Bonilla's office right now. Teachers, please allow these students to leave early. I apologize for not sending that list to you. There's about 40 students, and we just didn't have time to quite get the list to you. Students, again, if you are running for student representative, please report to Ms. Bonia's office. You are dismissed to come right now.
Anybody?
And also today at lunch,
What's
the
on video?
student speeches will be occurring right here at the quad. So if you want to hear these speeches, please come to the quad, and we'll start them promptly right as lunch begins. Thank you so much, and again, I apologize for the interruption. Bye-bye.
All right, you guys. Okay, so these are very explicit steps. Make a number line. Okay, this is velocity. Up here is velocity. Down here is time. Okay, showing when the object is stopped and the sign direction of the object when the as soon as t equals. Okay, so t is greater than 0. So when is the velocity stopped? So here the velocity is stopped. In this interval between 0 and 3, what is the velocity? So plug in any number between 0 and 3, like 1. When you plug in 1, what happens to the velocity? It's negative. So since this is the only time when velocity is 0, that means that it doesn't change, right? So it's got to be negative. Any time here, the velocity is negative this whole time. You get me? Do you trust me, even though we plugged in 1, we didn't plug in 2, that all these values will give me a negative? Because you know what? There's only one time when the velocity is 0, so then everything else has got to be either positive or negative. Okay? What about when number is greater than 3? Are we going to have, if you have a number greater than 3, the velocity is going to be positive. Okay, you got me? Now let's find the acceleration. The acceleration is a derivative of this, so it's going to be 2. So does the acceleration ever equal 0? No. Okay? So we're still, this is still t. Okay, so the acceleration is always going to be 2. So guess what? The acceleration is always positive. Okay? It's always 2. That's right. It's 2, right? It's important that you scale this line exactly like the number line. This is a nice little trick here. Now you're going to make a motion line directly below the last 2, putting all the critical values. That's a vocabulary word. The critical values is when v equals 0, okay? When v equals 0. So I'm putting the same critical values, okay? The v equals 0 at 3, right? Okay, so what happens to the motion? To get the motion, you multiply the signs, right? So if it's negative times positive, we're going to get negative. What is going on over there? Okay, and then 0 times positive is 0. Okay, and then we have positive, right? So what does that tell us? When you multiply them, if it's negative, it means that we are slowing down. Here we are speeding up. Based on the chart that we made above, does that make sense? Because remember, we're moving backwards, but the wind is pushing me forward, so I'm slowing down. Here, I'm moving forward, but the wind is pushing me forward, so I'm speeding up. Okay, so by kind of changing them into plus or negative signs and multiplying, we're figuring out if it should be slowing down or speeding up. Did you guys see that? See what we're doing? And if it was positive here and negative here, that means we're moving to the positive direction, but the wind is pushing me back, and so it would have been slowing down. Okay? All right, now make a position graph to show where the object is at critical times and how it moves. Okay? So we said 0 is important. At t equals 0, sorry. Since t equals 0 was important, and t equals 3 was important, right? So what's the position at 0? Plug 0 into to s. Shouldn't it 5?
No.
5. What's the position at 3?
It's gonna be
Negative 4. So what does that mean? That means, okay, let's put negative 4 here, 0 here, and 5 here, okay? That means what happened to my baby particle? My baby particle started where? At 5, right? At time 0, it started at 5. And then where did it go? It went all the way down to negative 4 And then where did it go after that? So it was moving to the left. It was slowing down. And then it turned around.
How do you know?
How do you know it turned around? Because the velocity was 0 here. So this tells us there's a turning point.
A lot of time.
Why is this a turning point? Because the
stopped.
velocity went from going negative to positive. So it went backwards and then forwards. If you're going from backwards to forwards, then you have to have turned, right? So this basically, this shows us the position and the time. It doesn't show us the speeding up part, but we get that here. So that's why these two are both, you need these two together to get the full picture. Where the position is and then whether it's slowing down or speeding up. So it was going doo, doo, woo, right? Okay? Sound effects included. Okay, so I'm really glad we got that far because now I can give you some homework. Yay! Okay. So how about we start off slow, okay? I don't want to kill you guys. How about, who has their homework packet with them?
Like the notes?
The actual packet. Here. Okay, so why don't you guys just do 1 through 4, okay? Just number 1 through 4. Okay, 3, 4A, number 1 through 4. It's basically what we just did right now. Okay? Robert, did you get the homework?
Yeah.
What is it?
4.
Okay, of which one?
The one that's next.
Yeah, so it's basically making, so for each problem, you might want to do it on your own sheet of paper if you want. You're basically doing this. Or you could do it directly on there. But you're doing this and you're analyzing the motion, okay? It's not that hard, but it is a little complicated because you're like, wait, you're thinking, is this position, is this velocity, is this acceleration, is it up or down or left or right? There's a lot to process, so you definitely need the practice. When you're riding a bike, isn't it confusing? Do I put my left foot first, my right foot first? Do I pedal forward? Do I pedal backwards? But once you practice, it's intuitive, right?
Right.
Same thing with swimming. Oh my goodness, try to explain to a kid how to swim. You have to breathe, and then you have to put your left hand, and then you have to put it over, and then make sure you don't sink, and you have to float. Once you practice, Robert, it's very obvious. Okay, bye guys.
Bye, Miss